So, yes, hello together to the last lecture in statistics this summer term. And what we were doing were some case study that, yes, we wanted to make a risk estimation of the capital market, especially from Germany. And we, if I find my mouse, where is it? To the left or to the right? Up. Where is it? Here is it. Okay. That we wanted to, let's delete this part, that we want to so estimate the risk of the capital market, especially of Germany, via linear regression using the so-called CAP-M equation, which represents the security market line, SML, which is quite the same as the capital market line, which we have derived from the Markowitz portfolio model. And if we look at this security market line, then we see more or less just a linear equation that we use some estimation for the expected value of the and the expected yield of some individual security. Here, one of the 40 DAX papers. And so we take the historical yields of these DAX papers and put in here RE. Then we take a representative yield, riskless yield in the capital market. And there we decided that we take the interbanking interest rates, the so-called Euribor, general interest rate, and that this term, if it's larger or less than 1, we could say that then we have a higher risk or a lower risk than some benchmarked market portfolio market yield. And for this market yield, we will take just a general index. And for Germany, we will take the performance of the DAX index. And this is also calculated with respect to the general interest rate in our capital market. So this is historical data, this is historical data, and therefore we have just a linear equation with actually the parameter of the vertical axis a equals 0. So there we just fix, so to speak. So this would be the individual, this would be the security, and this would be the index. And then we will fix our linear regression line that this has to go through the origin. Linear regression line has to pass through the origin. Okay, and doing this the last time we really talked the hard way in order to find all these data, and that you really, because in general you do not have access to Bloomberg or to other data services where you have to pay 100,000 euros for the license per year. How do we find this? And there we said that Yahoo Finance or Google Finance is quite a good source. Of course, the financial institutions like the central banks are good sources to find open data for these historical data series. And then I ask you that you should try it. And so my question is, have you managed it to get all these data? Oops, there's not. Where is this wieder? No, where is it? Yes, okay, great. Then, and this also via Yahoo Finance, you got all the data? Or took you another way? Oh, this yes was that you have seen. Sorry, I misinterpreted the chat. Because otherwise, then I downloaded all this data for you and you find it up on my web page. And for this, I recommend that you download the table below. Oh, you don't see it here. No, is it? This has to be here. And that you download case study. Where is it? Here you see it. That you download just this Excel data file. Oh, corona infection. This is not good. I had it before Easter, so I'm really sorry. I really hope that you have only an infection and that you are not that ill. Okay, no problem at all. So please give me back when you have downloaded the Excel file, because I think you should directly look in the Excel file that you know what I'm doing, because now we want to estimate these beta factors directly. So I also open the Excel file. I have the Excel file. Okay, great. So I'm on the wrong monitor. And then just open it. I also, no, this is wrong. So, and now this has to be around here, that you also see it. And then you have here all data in the first sheet. You have opened the first sheet. Yeah, okay, great. And then you see here, this is the DAX index, the history since 2010. And then you have here all our DAX values, Adidas, Airbus, Allianz, BASF, Bayer, and so on and so on and so on. And also, of course, data from 2010. But maybe you know it, that I think 1 or 2 years ago, we had a reevaluation of the DAX because generally it was the 30 more or less calculated via their market size, via their market capitalization. The 30 largest firms in Germany which are listed in Frankfurt. And then we had a recalculation that we now take 40. And actually, if you take these 40, then you have here also new companies like Covestro and also from the Daimler Corporation. They split up the truck building part. This is now a single firm also listed in the DAX. And if we go on the right here, then I'm again always on the wrong monitor. No, I'm on the right monitor. And if I go here to the right one, then we have really new companies like Delivery Hero. And if you go down, then of course these firms, for example, Delivery Hero started in 2017, and the split of Daimler DAX truck was even much later. This was just this year, I think, yeah, 2022. And for this, when we are in a minute estimate all these market risks, then you of course also have to keep in mind that you have here very new companies, and that the statistical results you get from very short historical data series, then yeah, you have to look at these results with, yeah, you cannot you can't hardly interpret the statistical result actually for the Daimler Truck company. But we will talk about this in a minute. So we have all the yield, we have all the data, and now we have to yeah, take the yields with respect to our interest rates. And the interest rates, where do I have it? I think just in the end, yes, here in the column AO, we have the interest rate of Euribor, and of course we cannot take the value minus the Euribor. We have at first we have to calculate the yield, and there we take the yearly yield, and this is then done in the sheet monthly yield. And if you click in here, for example, for Adidas, then we calculate here the monthly yield. So C60, oops, 62 over C26 over C25. And if you go back in the sheet all data, then this means we just start here in 2012. Split C26 over C25. Okay, so we then have the monthly. Oh, what did it do here? Send back. So, no. Oh, the 25 here is wrong. Oops. Always my mouse is missing. So, 25, back, enter. No, this doesn't work. Then delete it, and we take just this one. So Now we are back in business. So now we have the monthly yields, and now we have to subtract the yield of the Euribor, and this is then done here. So here you just see in this cell here the minus. So this one is the yield of our security minus the yield of the Euribor in column AO, if you remember. And of course, this one is then the right side of our linear regression, because this is the yield of the DAX minus the Euribor, and here we have the left side of our linear regression, our security Adidas yield minus the yield. Why is there not the saldo monthly yield minus? Oh yeah, here's the minus sign. Okay. So, and now we can take just, for example, one possibility. We take these two data series, and let's take another example. So here with the plus sign, you can create a new sheet. Let's call this Adidas. And then we will, I didn't copy it, again, this one. So this, copy, go to Adidas and insert. And now you cannot just paste it, because you have formulas. And therefore here you go to the numbers, and this means that you just paste the numbers. Unfortunately, then here the format has changed. There you have to go back to the format of date, and this you find here. And let's take this format, and then we are back. Have you also managed it to get the data in another sheet? Okay, great. So, and now we just want to make a linear regression. And I showed you the maybe most easiest way is just to insert here an XY diagram. Then we take data points, and let's see what is X and what is Y. So B is X, is the DAX, this is okay, and C is the vertical axis. So Adidas, this is also okay. And then let's put it just up that we are at the starting point. So this is your scatter plot. And now you see here in this cloud more or less that you have an ellipse or something like this, that if you just have a look at it, that you just would put by eye a line which is really moving upwards. So then you just click on the data, right mouse click, and trend line. Oh shit, now you don't see it, because now you have to manipulate here the trend line. That you go down linear is okay, but now you have to fix the cutting point of the vertical axis. You remember that we have no vertical axis number because we set this parameter a to 0. So you have to click on here, and here on the right side you have to insert a 0. And then we want to know what is the slope of our security market line, and we want to know the um, correlation coefficient. And so we also click on here, and then we have calculated the risk of our Adidas security. And there you see roughly 0.8 is the beta factor of the security. So Adidas, due to our linear regression, has a slight less risk than a DAX portfolio, or if you are buying the DAX itself. And also we have to look on here. This is the R squared, the coefficient of determination. And there you see, well, it is not that good. But at least we have almost, or at least we have a bit more than 25%. So our linear regression explains roughly 1/4 of the dependence between Adidas and the DAX itself. And this is, well, one possibility to calculate the beta factors. And if you know these beta factors, then you really can say, what kind of investor am I? A more risky one or a less risky one? And I'm always comparing with the market risk, and the market risk is represented by the DAX performance. And then I can say, well, the DAX is a bit too volatile for my investment horizon, and therefore I go and buy directly Adidas, because there I have less fluctuation compared to the DAX performance. Well, and this I have to do then for all securities, and this I have done here. And for this, of course, you can do it like I have done it right now by hand 40 times. And then maybe you are also interested in the S&P 500. You are also interested in the beta factors of the Nikkei, and so on and so on and so on. Well, then you have really a lot to do. And for this, of course, you can also use other formulas, and we do not want to go into detail here, but then you can use in Excel the formula RGP, and RGP means nothing else than just do a linear regression. And if you go to the internet and you just put in RGP Excel, then I think the first hint is you are can go to the Microsoft site web page, and here you find the explanation of the RGP formula, which just in general makes a linear regression and also makes a multiple linear regression for you. And actually, if you use this command, then here you find it. You find then M are the slope we are interested in. SE is then the standard error. And of course, here you have the R squared. And these three parameters are used then here. And you obtain these parameters then automatically. This is always the beta factor of the security, 0.8, 1.4, and so on. This is the standard error. So 0.8 plus minus 0.12 for Adidas. And of course, this is also a very interesting parameter to calculate is, of course, the coefficient of determination. And we talked about this, that then you more or less in a descriptive way, you can interpret how good, in quotation marks, is my regression. And here you see, well, if you take Allianz, the regression, the coefficient of determination is much higher than for Airbus. And maybe this is also plausible because if you take Allianz, one of the largest financial institutions which you have in the world, their portfolio is really spread into many, many investments that you also have here an beta factor in the neighborhood of 1 and a quite good correlation with the DAX performance is, I think, also quite plausible. And if you go to chemical industry, then you see here that you have a higher risk in the chemical industry and so on and so on and so on. And here you just can, for interest, you can also go through the data. Do I find something really interesting? Well, actually, if we take here Hannover Rück, this is for me quite surprising that you have here a lot much less risk than the DAX compared to Allianz, which was 1.1. Then let's compare Hannover Rück with the Murray, the maybe largest. Okay, this is also then plausible. Murray and Hannover Re has quite similar data points. This is also quite plausible because you have here similar companies. Oh, Porsche. Maybe if you are really a risk investor, then invest in Porsche, then you have a much higher risk than the DAX performance, which 1.5. This is maybe also the largest one, I suppose. More than 1.5. Here. So in the automobile sector, you have an investment which is much riskier than the investment in the DAX. And this is also, I think, a quite interesting result. And here, the yellow ones, I have marked these companies because these have really short histories. And then, of course, you see also here, you have an coefficient of determination of 0.05. So then you have more or less no result if you have an R in the neighborhood of 0. Here also for Linde, even it is actually more or less 0. And what else? Also here. In all these new companies, not quite surprising, you have a coefficient of determination which is quite in the neighborhood of 0. Okay, this from the content what I wanted to do in this term. Then we are through, and hopefully, especially this last case study is is interesting for you, because then you can really make your own estimation when you have maybe 5,000 euros and you want to invest this. Okay, then we have to do also an exam for this lecture, and for this we switch to the slides of the lecture. And in general, in the exam, we will do more or less all the exercises which we have done. So I will not ask you very general questions about what is an unbiased estimator or something like this, but we will do some little calculations which we have done throughout this lecture. Yes, this will be an open book exam. You can use all the slides, all the exercises we have done. And I also, on my web page, I uploaded you where you find it. And this you also should download, or you can do it by your own. Where is it? Here. Oh, where's the website? There's the website. Go back to my site. So it is here and here. So here statistical tables. Here you find the different distributions, normal distribution, t-distribution, chi-squared distribution. These three distributions we need. Or, of course, you can use Excel, because in Excel you, of course, also have all these distributions. And then what else do you need for the exam? And for this, we just go through the lecture slides, and I will mark all the formulas you will need. So we started with a general overview that I'm not starting from the very beginning. Then, of course, what is conditional probability? And of course, Bayes' theorem. There we had also some little exercises done for it. Let's go through it. Okay. Well, this is, I think, you know that you, of course, have to know what is an expectation value, what is the variance. The integral forms you do not need for the exam. Okay, then if you remember all the exercises which we have done, quite often we used these formulas and the general linear transformation of the variance and the expected value. This you should know. The probability axioms you do not need for the or well, if I'm calculate no the axioms you do not need, but the rules maybe you will need. Afterwards, I will upload these slides for you, that you know which formulas you have to know. Okay, conditional probability, of course. Remember the contingency tables we had. And yeah, please go through all the exercises which we have done. Statistically independent, this we also needed when we talked about contingency tables. An example, and total probability. So, okay, and this also was an exercise. Binomial distribution. Binomial distribution, we had also, I think, one or two exercises with the binomial distribution. So we will use binomial distribution, normal distribution, t-distribution, chi-squared distribution. I think the other distributions we do not take. So this, of course, then we need And yeah, no integration you don't need for the exam. Also here, this was also integration you don't need. So this you don't need. You also do not need the uniform distribution for the exam. So then, yeah, let's also cross all this. So well, actually afterwards with when we calculated confidence intervals, we use this formula more or less, but we only insert it and we look it up in the table. So you do not have to calculate, you do not have to integrate. Let's do it like this. You do not have to formally integrate. So where we are again. So of course the normal distribution we need, but of course you do not have to insert in this formula. But what is the normal distribution, especially with these two characteristics? Importance of the normal distribution. Well, you do not have to learn all this. And yeah, this transformation, this is really important, especially when we do hypothesis testing and we are calculating confidence intervals. This you really have to keep in mind. Then the interpretation, that this is then the probability, of course. And of course, you always can look up these numbers. But if you, for the exam, have these numbers in mind, then you do not have to look it up. So the confidence intervals 90, 95, 98, and 99%. And please remember one-sided or two-sided, because this 2.33 or this 1.96 then means if you have a one-sided, then it is 10%, and here it is 95%. Please remember this also, that you do not mix it up if I pose such a question. Okay, there central limit theorem in general, but I also will not pose a general question. But of course, you should know that the central limit theorem just means that everything will reach the normal distribution. Then estimation and testing. Our estimators, of course, the mean. The mean if you have a proportion. This also if you have the explicit numbers. And this is very important, the unbiased estimator for the variance, and especially that in this case you have to divide by n minus 1. So what is an unbiased estimator? Of course, you should know. Asymptotically unbiased estimator, efficiency, and sufficient. Consistency first, and then the next one should be sufficiency at the last one. So here we had also some exercises. There you also have the solution within the lecture. And then what is a confidence level? Of course, you have to have an understanding what is the confidence level, one-sided and two-sided. I already talked about it. So one-sided then means this is my distribution that you go here to infinity, and two-sided if you take two borders. So in this case it would be this area, and in this case it would be this area. So calculating the intervals, this would mean, and this you should keep in mind, if you have a large sample size, n larger than 30, then you take the normal distribution. If you have a small sample size, then you take the student distribution. Yeah, I think this, of course, generally you have to do it, but you can assume if I pose a question in the exam that these conditions are always fulfilled. So, and now you need the formulas, and this is then the formula with for z is the value from the normal distribution, and this is then the formula in order to calculate your confidence interval with normally distributed random variables. Then you just interchange the z value with the t minus 1 value. So this is for the t distribution. You do not have to learn how the t distribution in general looks like. This is, I think, higher mathematics. And then, of course, here we had some examples and the formula for the proportion and the formula for the chi-squared distribution. And keep in mind that the chi-squared is not symmetrically. Yeah, because it looks like this. Yeah, here we have it. Okay, this you also do not need. Here an example. Then hypothesis testing. Left-sided, right-sided, two-sided. This is coincidentally with the two-sided or one-sided confidence intervals. And then we, for the exam, we only look at the alpha error. And yeah, maybe if you have this picture in your head, then I think you also know what you are doing when I ask you to do hypothesis testing. So, and then the hypothesis testing for the mean with the z value. If you have a large sample size, and the t-value test statistics if you have a small sample size less than 30. This is testing for the mean. Then we test for two means. Then you also have to calculate the aggregated variance. testing old only for the mean, then in general the variance will be directly given. And the test for proportion. Also, always keep in mind that you really accurately formulate the null hypothesis and the one hypothesis. Where do we have it? Here, here, yes. Testing, 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 and we also yeah, tested then the chi-squared independence test, and here think of the contingency tables. Actually, my son just does statistics. He is in the 6th class today, and with him I also calculated contingency tables because he just did, what did they do? The relative probabilities they calculated. Yeah, here I have the example. So this was one example, and from this example we obtained the theoretical and the empirical probabilities, and these theoretical and empirical probabilities have to be inserted within this formula in order to calculate the chi-squared value. And with this chi-squared value, you then go into your distribution, chi-squared, and let's say x, and then if we say this should be 95%, and if our empirical chi-squared value is outside this area, then we will reject the null hypothesis. Okay, then we have made the descriptive linear regression. There we had our examples doing our regression. Do I have here a diagram for this? Yes, here. How to calculate this regression line, and for this we formulated our optimization problem, taking the derivatives with respect to A and B. We obtain these two first order conditions, and from these two first order conditions we obtain then these formulas for our two parameters A and B. Well, if I ask you to do a linear regression, then of course you can do it by hand using this formula. It is an open book exam, but you also of course can use some software package, especially Excel. We have done it quite often in Excel. And then I will formulate in the exam that you just should write down what you do. And if you, for example, use Excel to solve the problem, and then just point out that in behind within your software package, of course, this software package has used this formula in order to calculate the parameter A and B. And if you then just copy this formula and say, well, this is what I have done, and this has done Excel for me, then everything is fine. Because I only want to see that you know what you are doing. Okay, these were all the examples. You also can do it a bit slower, that you at first calculate all these medium values you need in order to insert them in this formula. How you do it, this is up to you. Okay, and of course also the correlation analysis, which is defined in that way, the covariance, and then we obtain the correlation coefficient via this formula, and the correlation coefficient is directly connected to the slope of the linear regression line multiplied by the square root of variance x over variance y. Okay, and then of course we also had the coefficient of determination, which is just the squared correlation coefficient, and this coefficient of determination we could nicely interpret that it is just the proportion between the explained, where is it here? The explained difference, and this is the total difference. And therefore, we roughly can interpret this coefficient as what percentage is our linear regression explaining. And this is then also another possibility how you can calculate the coefficient of determination. Well, then we are more or less done, because I will not ask you here the Markowitz portfolio model. This I will not ask you in detail. This is then was due to that we can do our case study. Though this you do not have to learn for the exam. And therefore I'm now done with the lecture. And oh, maybe we can go through the, oops, where is it? Some exercises where I can show you. Where is it? No, here. This I also wanted to show you. Well, of course, this was a contingency table. Well, let's say this one. Oops, no comment. That's not working. No. Why is it not possible to comment? Yes, no. So this one. So this you do not need go through it. Then this were some examples. Okay, then go to exercise 2. This was all the confidence intervals. And 3 here, especially, we also did, let's say, some theoretical derivations. This you should look on, and within the lecture, if my memory is right, then go back here, up. No, this was this lecture, the general lecture was here. I think we had here also some more theoretical problems. And this was, I think, this part here. So let's do it also in red. That you also look at this theoretical exercises. Maybe from these exercises I pose a little question in order to show me that you have understood this part. And actually we had this nice, no, I think this was also in the exercise sheets. Maybe here. No. Okay. But that it is. Hopefully you know now what I want from you in the exam. So go just through all our exercises and which I showed you here. Any more questions? Yeah, for sure. Yep. It is called Hausarbeit, but it will be 90 minutes. Within 90 minutes, then you, I will pose you here some questions, and these questions will look like these exercises here. Yes, so we have an online Moodle course. There I will take all the guys which want to write the exam, and then you are invited to join, and then you have to upload after 1.5 hours your solutions of these questions. Yes, of course. Yeah. I have to look it up. Where is it? And you have already said that you want to write the exam because you are an exchange student. You, but then you can look into your account that you are really um, have done it. Yeah, the e-campus uh, is the important thing. So Moodle is if you take only Moodle, then I don't see that you are really want to write the exam. Yeah, you have to do it in the e-campus. And there you have done it? Okay, okay. Then, yep. Mhm. Which one? I open it just. No, this is not. Here we are going back, and so which one is not working here? Oh yeah, this is not working. This will work today. This is then the things here. No, not this. This sheet where I marked all the formulas you need for the exam. This I will upload for you. Yeah. And then just look at it, and you can use, of course, this one afterwards for the exam, or you take all the formulas outside out of these slides and put it in another way for yourself. So it's just up to you how you do it. Yeah. So this one will be then found by the link formulas. Okay. Yep. And if you have then further questions, just write me an email or something like this. Okay, further questions. Then I will end.